Good morning. This is the coal-fired power webinar this morning, and Scott Affelt will be joining me as a speaker. I will be taking the ball here to begin with, and then turning it over to Scott for a period of time there, and then we will be taking questions anywhere along the line. And let's see, I want to get down to the first slide here, which is a table of contents. And so we're going to go through the markets first, and then a 5-step business program. Then Scott's going to get into the data analytics, and then we're going to go to our website and display some of the analytic activities in coal-fired power plants. So let's see. Whoop. Yeah, so we're getting into the markets next. And let's see, that button doesn't seem to be moving down. I have to do it by hand here. So the replace and repair market is going to be considerably larger than the new market in coal-fired boilers. And the way we calculated that is just how much increase in coal-fired capacity there's going to be in the various countries around the world and regions. And as you can see here, that you've got negative growth in NAFTA and West Europe, and you've got fairly robust growth in West Asia. But since most of your components last less than 10 years and none of these areas are growing at 10%, the ratio of repair and replace is much higher in all these regions. And then when you add in a new dimension, which we call a sea change in the whole market, which has to do with the introduction of IIoT, data analytics, remote monitoring, etc., then you've got a much bigger opportunity at existing plants than you do at new plants. So you can just compare this for particular components. So this high ratio of replace to new requires an adjustment in sales strategy as well. Most suppliers rely on sales leads rather than targeted efforts. The replace market is predictable and needs to be addressed by targeted efforts months in advance of any order. Most large coal-fired boiler operators are embracing IIoT and data analytics. This gives them the ability to make purchases based on the lowest total cost of ownership. Actually fewer than 200 coal-fired utilities will buy most of the replacement and upgrade equipment. Profiles and plans for each of these utilities are included in our tracking system. And just to give you an example, for instance, for one company, you've got Shenhua Guodian, who just merged, and Guodian was the second largest coal-fired power plant operator in China. They also have a quick equipment decision, which is the largest air pollution control equipment supplier in the world. They have 225,000 megawatts of FGD systems, whereas here in the United States, our total installed FGD is only in the neighborhood of around 50,000. So they have more than the entire U.S. They have more than Europe, etc. And the same thing on DNOX. They have well over 100,000 megawatts of DNOX systems. But Shenhua is the largest coal mining company in the world and also operates a lot of power plants. So those two entities have merged. So you have this huge potential purchaser of coal-fired power plant systems, and not only for China but all over the world. Guodian is doing very well now in Turkey, where there's a lot of Chinese investment to help the Turkish coal-fired power data inventory grow rapidly, and so they're investing in a lot of these plants. And so there are a lot of Chinese suppliers and a lot of things going on. Erdogan is relying on a program to boost his power tremendously using the domestic lignite. But utilities replace entire boiler systems rarely, if ever. By contrast, new dust collector bags are purchased every 2 years. Treatment chemicals are purchased continuously. So, for example, the treatment chemicals market is 99% of it is in plants that have operated for more than 1 year. And the revenues coming for the various different components are showed on the right-hand side here as a ratio of initial first year versus the average in the first year of operation for as compared to all the plants that are in operation. So again, with valves, pumps, and compressors, the market is 10 times larger at existing plants. The other thing is that there are relatively few companies that are making all these purchases. And so we just looked at the flow and treat purchases, combust flow and treat by company. And you can see one of the largest U.S. suppliers is going to be spending $1.68 billion a year, but the Tang is spending $10 billion. Guodian, now that you add Genoa to them, is up in the neighborhood of 18 or 19 million. So let's go on to the next slide here. And so now Genoa is merged with Guodian, so they have another 6.8 billion a year in combust flow and treat components. So you've got a huge purchasing power just of those two merged entities. So this is looking at just the FGD portion where you do have some new equipment. So somebody like Escom shows up because they have new FGD systems going in, so they show up to in a higher number for that reason. But again, it's mostly the companies with the large installed base of FGD systems that are buying the components, and many of them are the Chinese companies. And there's J-Power, for instance, but is another out of Japan. So it gives you, I think, a sense there. The other aspect of sales to the industry is the EPCs and OEMs. So the top 16 operators would be buying 40% of the components. The top 16 EPCs and OEMs selling to those operators would be another 12%. So the smaller EPCs, 3.8. So to the top 16. So one way or another, the top 16 operators are either buying or directly or indirectly, more than 56% of the components. And then the EPCs for smaller operations, another 15%. So when you add the top EPCs and the top 16 operators, you're up already to 70% of the market. And then we get the smaller companies, operators, and the smaller EPCs, and that rounds out the total. But again, it's a relatively small number of players here that can be targeted. So there's a 5-step business program that we believe is success needs to be implemented to maximize success for the components for the suppliers of the components that go into coal-fired boilers. I should say components and consumables. And step 1 is advanced forecasting. And there is a vast amount of available information. So there's an ability for a company to create continuously updated bottoms-up forecasts with millions and millions of numbers that become quite relevant and useful. And with that in mind, companies can budget R&D in the areas that are large enough to warrant it, and increasingly knowledgeable corporate personnel will buy from suppliers who can demonstrate the lowest total cost of ownership for not only the basic products, but for support products and services. And some of the data analytics that Scott's going to be talking about here a little later arm the owner with this knowledge about what the cost of these products is, and therefore someone with a better product is going to have a sympathetic ear. So the large prospects, again, are the big purchasers, and they can be identified, and they can be identified because they're going to be making long-term decisions, and this allows the vendor to work with these large purchasers continuously and not wait for an RFQ. Selling to a knowledgeable corporate long-term decision makers requires a whole new approach, and the use of digital media is part of all that. And then sales persuasion really requires application experts who can influence sales based on high-level communications and knowledge. So a number of approaches need to be addressed. We're saying that there's really a sea change in the way that the market will be approached because of the IIoT, remote O&M, and just what we call the industrial internet of wisdom, which is the interconnection of knowledge and people, which is something that we are pushing very hard on. But the advanced research, rather than top-down periodic general guesstimates, it will include bottoms-up forecasts, as we've been talking about here. But the total cost of ownership analyses used to be expensive and inadequate, but now they can be voluminous and continuous. The acceptance of new and better products was slow. It will be rapid. Selection criteria has often been based on price and service because the TCO was not available. Now that it is, that will be a major, much more important factor. The component supplier role was often just initial sales, spare parts, and service on demand. In the future, it would be cloud-based continuous involvement. And in terms of product identification, certainly location of specifiers, the emphasis has been individual plants, but in the future, the corporate staff with TCO data is going to be making many of the decisions. A sales initiation will change from uncoordinated sales leads to identification and pursuit of the large prospects. Sales persuasion will, instead of sales experts, will be certainly pursued by application experts who can deal at the same high level of knowledge that the client has due to his data analytics. Collaboration with other suppliers has been haphazard. It's important to success. Part of this whole industrial internet of wisdom is the interconnection of all sorts of different people, including one supplier with another, and understanding of all the aspects of the processes and materials and plants themselves. And the decision process has not been systematic, but in the future there'll be more and more decision systems that, again, interconnect knowledge and people. Subject matter experts in the past have not been well utilized and have lacked the ultimate knowledge that is available due to all the random information that can be now accessed. But with decision systems, subject matter experts can become subject matter ultra experts. Remote monitoring was unusual in the past. It'll be prevalent in the future. Data analytics was unusual, be prevalent. And third-party operation was minor and will be major, and certainly third-party advice is going to be huge in the future. So the step one is the advanced market research. We've gone through the fact that a few companies are going to be making those decisions. Therefore, the end-use geographical locations will be more important for service rather than sales. So the new approach requires market forecasts, which are detailed and accurate enough to become the foundation of a sales program. So it's now possible to create millions of forecasts and continuous updates. And these forecasts need to be based on a thorough understanding of the processes, products, and market dynamics. We're leveraging over 40 years of experience following all these industries and markets to bring to this. But we believe that the starting point for a lot of the suppliers is focusing on the IIoT and remote O&M, and we do have a report that covers just that for all these different industries. And there is a sea change in the obtainable market, and the fact that MHPS is operating a remote control center in the Philippines and remotely monitoring coal-fired power plants in Asia is symptomatic, I think, of the future. But we do believe that there is a new opportunity for coal-fired power plant suppliers based on what we call the wisdom-based obtainable market, or WOM. And we have several people from DOE who signed up for the webinar this morning, and they have a mission of understanding the needs, clean coal needs of developing countries, and seeing how American technology can be applied to those countries. And we would, but we do believe that this is going to be a very valuable endeavor, and that the biggest potential for the U.S. and coal-fired power plants is not building a lot more coal-fired power plants ourselves, but providing the wisdom to help coal-fired power plants around the world become more efficient and use a lot of the innovative technology that's resulted from all the experience that has been obtained in the U.S. And keep in mind that the U.S. for a very long time operated more coal-fired power plants than anyone else in the world up until the recent Chinese surge. So the WOM opportunity is much larger than the SOM. So the serviceable available market is relatively small compared to this wisdom based market, which would include a data analytics package, and we'll be getting more into that with Scott's presentation. So on the product evolution, there is a definite need to do the R&D, and I was involved in, fortunately to be involved at the cutting edge. My little company was approached by Combustion Engineering in 1965, and we were picked to having the leading edge technology to start the whole scrubber industry in the United States in power. And we were very pleasantly surprised when they said they had $25 million to help us do the transition from providing scrubbers for pulp mills and waste incinerators to for power plants. But we saw a number of years there, maybe 4 or 5 years, where essentially any research funds that were necessary were available, and we saw a lot of progress in that period. But I would have to say we then were acquired by another boiler company, and all of a sudden, with the twists and turns of the industry and the valleys after the peaks, that all of a sudden all the R&D disappeared from the industry, and literally a lot of our scrubber designs, for instance, today are not a whole lot different than they were back in the early days. So I would say, as a country and the companies that are expecting to dominate the international markets, you've got to get back to doing some of the R&D that made for so many big strides forward in the early days. So the power of innovation is what we've really been talking about here, but we have lots of examples that are going on in the IIoT world in coal-fired power plants, and I would cite Primax, for instance, who is helping the dry scrubber operators with using OSI soft process management systems, but also providing the subject matter ultra experts to make all sorts of improvements. And this is the type of effort that could be widely applied worldwide. And so we see this as a huge opportunity for many of the companies in the United States. So just some of the examples of what can be leveraged. There's a new catalytic filter that can make all sorts of difference. There's all sorts of minor things from the valves and the pumps and so forth that have proven their worth here in the United States. But here's one example. United Engineers came to our little company again back in about that same time that Combustion Engineering was working with us on limestone systems, and had a project to make sulfuric acid from power plants in the Philadelphia area. And ultimately, there were 4 or 5 of these systems installed in several coal-fired power plants at Philadelphia Electric. And the scrubbers that we furnished actually took out the particulate, the HCl, and then you went on to the SO2 scrubbers, which were Magox scrubbers, and there was a magnesium sulfate end product that went to Essex Chemicals, was converted into sulfur products, and the MgO then returned to Philadelphia Electric. But right now there is a variation on that could make a huge change to the coal-fired boiler industry around the world. We accidentally, in this scrubber that you're looking at here in blue, we're actually making a perfect rare earth feedstock, because you've got all your rare earths in very fine micron form, and they're being caught in a 30% hydrochloric acid recirculated solution, which can then be discharged to a leaching operation, and you end up making rare earths as a byproduct, hydrochloric acid as a byproduct, and a very pure, and from your second scrubber, which could be a gypsum scrubber or otherwise, but if it's a gypsum scrubber, you make a very pure white gypsum that can be used to replace precipitated calcium carbonate for magazine and high quality paper coatings. And ultimately, in actuality, a system like this is really no more expensive than your conventional FGD particulate system, and yet has all these byproducts. So we see this as a type of development that can be exported around the world. One other aspect I might say there, though, is that we have to not get ourselves into what they call silos in one of the more recent books. And the municipal waste incinerator industry in Europe has a similar setup to this, and they're recovering metals, valuable metals from municipal solid waste, but they basically have a very similar setup. But one aspect of that can be incorporated in this is removing the mercury and other toxic metals from the hydrochloric acid, because a buyer has an ion exchange system just for this, for the municipal waste incinerator plants in Europe. So again, having the knowledge of what these other industries is doing is helpful as well. So the lowest total cost of ownership validation, we believe, will be essential for high performance combust control and treat products and services success. And there are a number of criteria that are necessary to provide an accurate LTCO. So you have to address the unique process parameters. There has to be validation by a subject matter ultra expert. In order to validate a lot of these process parameters and cost factors, it is very desirable to have decision systems that lay out all of the background information, so it doesn't have to keep being reinvented, and therefore it has to be kept current, and it has to be exposed to third-party criticism as well. So a lot of this can be augmented by the decision systems themselves. So we do believe the industrial Internet of Wisdoms will be leading the way to a lot of this type of effort. And then again, going back to all these ways that the LLT's total cost of ownership has to be maintained. And then we get into prospect identification, where we have lots of services like the tracking system and coal-fired boiler decisions and the industrial internet and remote O&M. And then for sales initiation, we're working with companies where we're helping them set up websites, because you do need to coordinate all the different salespeople in all the different regions. If you're working, for instance, again, let's say with Shenhua, Guodian, and they have and they're selling plants in Turkey as well as in China. You need your Turkey people as well as your China people all on board in anything that you're doing. So the other thing is that it doesn't make any sense if you've got a valve group and you've got a scrubber group. Somebody like Andritz, for instance, that has the scrubber groups, they've got valves, they've got pumps, they've got all these different things. It doesn't make sense to be calling on customers that are going to be buying the same customer, and maybe even some of the same people will be buying from 3 or 4 different divisions of your company, and to have no coordination between those divisions doesn't make sense. And then, of course, with IIoT and remote O&M, not only should these divisions be coordinating with each other, but you should be looking at packages that maximize the value of each of the components. And then sales persuasion, I'm not going to get into all the details again, but again, participating in these decision systems, developing subject matter experts that are either part of your staff or are outside subject matter experts that can validate your and advise you are, I think, going to be critical in the future. And there are decision systems that we already have that do reach the decision makers. They're usually free to the utilities. And so you do have live personal contacts and with the webinars, and then work with this user group. So like with the dry scrubber user group, meets once a year in the US, and we're hoping to work with them and make this more international, and also add webinars and other useful intermediate ways to interconnect along with the decision system, which we already have in the dry scrubber area. And for instance, right now there is a big interest in dry scrubbing in Turkey because of the lignite and the circulating fluid bed boilers. So that is completes that aspect there. I'm going to end the discussion here and move back to the exemplar edge analytics PowerPoints. But in fact, that's right. I forgot what that we were going to do. We're going to actually go the other way and make Scott the presenter, aren't we? So going to change.
Yeah.
Yes, okay. Let's do it that way, because you've got the some
action.
I've got
the animation. Yeah.
So we will be making Scott the presenter here. So let's see. Change presenter. So it hasn't happened. I'm going to hit change presenter again. Hit Scott Affeldt. Yeah, I don't think that's happened yet. Let's see. Okay. Oh, okay. No. Okay. I first got it. Scott. Okay, I'm gonna.
Yeah, I think you're there, right? Can you see my screen?
No, I don't see your screen yet. Maybe.
Oh, okay.
Oh, I guess maybe I do, but yeah, we are seeing your screen. Okay, sorry.
Okay. All right. Well, let me get started. Let me first introduce myself. My name is Scott Affeldt. I'm with Exemplar Energy. We're a consulting company focused on helping both customers and OEMs prepare strategies, market entry strategies, digital strategies, technology liaison and partnering, and also data analytics. Bob has invited me to talk about, we do a lot of work in.
Yeah, we're just making sure that we get, okay, yeah, now we're on to yours. We were still on ours. Sorry, Scott.
Okay, gotcha. So, so Bob had asked me to talk a little bit about analytics. I've talked at some of these seminars before about analytics and remote monitoring. And this presentation is focused on a topic called network edge analytics. And I'll explain what that is and how it might apply to the coal industry or the power generation industry. So first, what is edge analytics? You know, there's a lot of terminology around big data and remote monitoring and analytics. Well, edge analytics is where you collect and process and do the analytics right at the edge of the network, at the sensor, or at a network switch, or right at some device. So this could be, instead of taking the data back via the cloud and doing the analytics remotely, this is being able to actually do the analytics right there at the device. And this can then be performed in a more real-time, in situ basis, because you're now doing the analytics right there where the data is being collected. And the kinds of analytics that can be applied here at the edge, they can be descriptive or diagnostic or predictive. I'll explain a little bit about the difference between those types of analytics in the next slide. But the whole point here of the edge analytics is to do the right analytics at the right time at the right place. So part of any analytics solution is trying to unlock the value that you can create from analytics. And for the most part, what's happened in the past is what's called descriptive analytics. And this is trying to do analytics around what happened. So you're looking historically at what happened, trying to see problems or anomalies that might have occurred that could be an indication of a problem. It's really based on information, and for the most part, it's based on hindsight. Going forward, we see advancements in what we would call diagnostic analytics. And this is trying to create some context around why did this problem happen, not just that something happened. So we're trying to use the analytics to help us determine what the cause of the problem was, not just to identify the problem. The next step is what we'd refer to as predictive analytics. And this is trying to put some time context around the problem. Not just determining there's a problem, not just determining what the likely cause of the problem would be, but also providing some context into, well, how much longer do I have before that problem becomes a catastrophe or a failure or exceeds some performance limit. So we're trying to put some time element around the problem, and this starts to get into the predictive aspects. So we're trying to look back into the future to give us some indication on how we can manage the risk around that. The holy grail of all this stuff is what is being referred to as prescriptive analytics. This is what really provides the actionable information about a potential problem, using analytics to help us determine, well, what should we do about it? What action should be taken to either eliminate or address or reduce or fix the problem that we've identified to help us manage the risk of that problem. So this is a very action-oriented. For the most part, this is where we see a lot of activity in the analytics area. Predominantly at this stage, it's around exploring new applications with respect to diagnostics and predictive analytics. Quite honestly, we really haven't gotten to the point of prescriptive analytics yet. That's clearly on the horizon. You might see these IBM Watson commercials. They talk about everything happening automatically. We're probably not quite there yet. Diagnostic and predictive analytics do rely heavily on our subject matter experts that Bob referred to. We're not eliminating them, we're just trying to leverage them using analytics. All right, so what's the difference between the edge and the cloud? So this graphic is really trying to illustrate that point. The cloud is where we're using the internet to gather information, transfer the information to another site, could be a headquarters, it could be the OEM, where we're actually doing the analytics remotely. The edge is where that's going to be located more at the device level. So it's going to be closer to the valve or the pump or the wind turbine, but it's clearly going to be analytics that are performed at the site and much closer to the device than just at the site control room, for example. You know, we're talking literally out there at the site level. And that information can be transferred via their local LAN or local WAN, and maybe these analytics are done at some gateway or router level. The difference, though, is in that the cloud is more of a centralized remote analytics, and the edge is a more decentralized local analytics methodology. So what are the drivers for edge analytics? Well, first of all, the Internet of Things, as Bob's mentioned, is rapidly growing. There's more sensors out there. There's more data out there than we've ever had before. And it becomes a little difficult to manage all this data at a central location. The volume and the velocity of data is increasing exponentially. So how much data we're getting now is much more than there was in the past. And the frequency at which we're getting the data is also much more has increased substantially. You know, typically when people are doing remote monitoring for power plants, they might be looking at data every 5 or 10 minutes at frequency. And there may be situations where the frequency of the monitoring might need to be more frequent. And in order to do that, you just can't send the data via the cloud, do the analytics, and get it back there really at the frequency that's needed. And so in order to accommodate that, You really need to do the analytics right there at the device level. What Edge Analytics does is it reduces the burden on the network. So you don't have all this data having to go through the cloud. You can selectively use data that's created right there at the device level and make analytic decisions right there at the device level, and then ultimately just transfer the required or the necessary or a selected amount of data via the cloud. So this reduces the amount of data that's being streamed. It also reduces the connectivity costs because you don't have to accommodate not only the data transfer costs, but then also the storage and the management of that data. I mentioned earlier the latency. So if we're trying to do real-time analysis, could be by the second or even the millisecond, the latency of getting that data up to the cloud, doing some analytics remotely, and then getting information, actionable information back is just not acceptable. So we can do those analytics right there at the device level and really address this latency issue. By not transferring the data, or not all of the data anyway, through the cloud, we eliminate or at least reduce the issues around data security and cybersecurity. So we don't need to send all of the data through the cloud. We can be a little bit more selective. And then generally, when you're relying on the cloud, you're putting the reliability of that information at risk through the internet. While certainly the reliability of the internet is high, and there are some things that you can do to address that with respect to T1 lines and what have you. In general, the local area networks tend to be a little bit more reliable. Or if you're getting information directly from a sensor or a device, could be hardwired right to a gateway of some sort, the reliability of that connection is going to be much higher. And the final thing is you can scale these things up fairly easily. So you can monitor a lot of devices or equipment at a fairly reasonable price, and that's important if you want to extend your analytics to a wider range of assets.
At this point, Scott, before we move from that, the individual component vendors, let's take a valve or a pump company, for example, or a scrubber company, they have a lot of knowledge about how to operate that device, which I would assume can be incorporated in the edge computer analytics and software, and therefore they would be offering a knowledge aspect to their offering that certainly enhances the whole cloud-based process management system, but also gives them a clear revenue stream from the knowledge that they have that might be lost, would it not, if the cloud-based supplier is trying to integrate knowledge about how to operate a pump or a valve or a scrubber without the benefit of the supplier.
Yeah, exactly. I think there's a unique opportunity for the OEMs right now with respect to data analytics to do exactly what you described. To leverage the expertise they have about that specific equipment. And that knowledge, that subject matter expertise can be embedded in the analytics to look for things or combinations of things that just a normal user wouldn't have the expertise to really interpret or understand on the one hand. And here we're using analytics much more than just typical trends. We're not trying to necessarily only look at these edge analytics as, well, the temperature's going up. That's fairly easy to do already. What we're trying to do is monitor the combination of a number of different sensors that might impact the performance or the reliability of that piece of equipment, and look at the combination of those sensors to provide more insight into how that asset is performing or how reliable that asset might be. And it's that knowledge of the interreaction between all the different measurements parameters around that asset that typically the OEMs have a much greater knowledge of. Now, the second piece of this, you kind of touched on it as well, and I mentioned it earlier, with respect to diagnostics. You know, the OEMs are in the best position to then interpret those combination of parameters or anomalies. For example, if the temperature is high and the flow is low and the pressure is high, you know, what does that mean? And the OEMs can then provide that as a service back to the users, the owners, in terms of interpreting the combination of these analytics to provide some guidance into what the most likely cause would be. And the OEMs are certainly in the best position to provide that kind of information back to the users. And as you pointed out, most likely this would be a more outcome-based or results-based or subscription-based service of some kind that can provide some recurring revenues and allow these OEMs to really leverage the subject matter expertise they have in-house.
And just let me ask you one other question there too. Let's take the temperature example that you made here. If you're operating, you know, a valve or a pump or whatever, you may have the best insight as to how to deal with increases in temperature in terms of the operation of your valve or pump. However, the cloud-based system would be obtaining data from the broader picture and the OEMs for the whole boiler system, and would be able to predict changes in temperature that might therefore need to be, through data analytics, connected to your knowledge about how to operate a pump. You know, if you're anticipating a higher temperature, what you would know what changes to make in your pump VFD or whatever here to take advantage of that. But you would have to be integrating that with the predictions of the temperature increase that's coming from your cloud-based system. Is that a simplistic but accurate thought?
Yeah, I think so. And I think this, what we kind of see is this combination of edge analytics, which is more limited to the information that's right there available at the device level, and a cloud-based system, which, as you pointed out, takes information from a broader source or around the plant to provide more context around that. So, for example, if the temperature at a valve is high, well, that could be the valve is failing, or it could be that the plant is just running at higher load. You know, and so by getting the benefit of the context of that temperature, by looking at a broader set of data through the cloud, then you can add more value. And so later in a couple slides down the road here, we'll show how both the edge analytics can provide this real-time analytics, but it also fits very well with a cloud-based remote monitoring, and these OEMs can provide both.
Well, thanks. That answers the question.
Okay. All right. So how does this work? And actually, what I'll do is I'll explain how the cloud analytics work first. I'm using a wind farm as an example here, but this would apply to a pump or a valve or any kind of equipment that might be located at a plant. So typically for cloud analytics, all the data from that plant or from the remote wind turbines is sent via the cloud to effectively some central monitoring center. And this is things like the wind speed and the turbine speed and the vibration, temperatures, pressures, whatever. All the data that's relevant to that particular piece of equipment and how it might be operating from a performance or reliability standpoint. And then the analytics are performed at this central location, and actionable information then is teased out of those analysts. Could be that this particular process is not operating at the expected level, or whatever the conclusions are. Then that information is fed back through the cloud back to either the operators or the plants themselves, and for some action. So in essence, data is sent from the asset through the cloud to some remote monitoring center. Analytics are performed and actions are sent back. That's typically how the cloud analytics work. And this is how people are doing remote monitoring now. Bob, you mentioned the MHPS guys and Luminant. This is typically the concept they're doing right now, is getting that data through the cloud, analyze it, and providing some actionable insight. It could be anomaly detection, it could be diagnostics, whatever. Now, when we talk about edge analytics, it works a little bit differently. So here we have the same set of remote wind turbines, and at each turbine there's a gateway or a router or a server of some sort. And now, first of all, we create predictive models at the central location about how those turbines should work, and and the relationship between all the data that we're looking at. And those models are deployed remotely to each one of those wind turbine gateways. And then in real time, data is collected from the wind farms, or the assets in this case, and it's collected at the gateway level. So these are actually at the device level. So, the gateway literally is inside of that each wind turbine. And again, we're analyzing that same kind of data, maybe on a more higher frequency than we would be able to otherwise. And through the analytics, we're comparing what those relationships should be against what they are, and we're effectively using those to help us detect anomalies. And because we're looking at this information in very high fidelity, high frequency, we can then create some automated actions that can immediately be fed back to either the operators or the plants themselves to make adjustments in terms of how they're being operated. And all that happens really at the device level. Now, all the exceptions and maybe some other contextual data can still be sent through the cloud, but now instead of sending per second data or even millisecond data, now we'd only need to send the exceptions. Just tell me about the problems, and then give me a less detailed assessment. So maybe I only need data every 10 minutes. If things are running fine, I really don't need the high fidelity data. I only want to know about situations where it's not running fine. And so we can use the cloud to then send that kind of information back to the remote monitoring center, where they can analyze it at a higher level, and then also incorporate some of the broader aspects that might be impacting the performance, the reliability, or even feed into their business intelligence analytics platform. So hopefully this shows a combination of doing analytics at the edge, which is a real-time, very fast, high frequency, high fidelity analytics, but also then using the cloud to send the anomalies back to some remote center. This could be the OEM, or it could be the generation owner's headquarters, with more less detailed information.
One aspect here that one maybe example of this in a crude way is Duke Power, who who has wind turbines from a number of different sources, and they're getting all sorts of feedback from each one of the 3 or 4, Vestas and GE and so forth. But they felt that they needed a system that would allow them to look at all the data, not just from one vendor. So it seemed to me that whether they went this route or not, this is essentially the flow diagram that they would be pursuing in order to analyze this data from all these different turbine vendors.
Yeah, well, actually what Duke's doing is the cloud analytics. This is the model they're currently using right now. They're collecting data from each wind turbine, sending it through the cloud back to their central monitoring center in Charlotte. I believe it's in Charlotte, and analyzing the data there. And that's an easier thing to do. The next step for them would be to go to this edge analytics approach with a combination of doing some of the analytics right there for each turbine. And again, part of the problem is there's so much data being collected because you have hundreds of wind turbines out at each farm.
Right.
And so if you're collecting data on a per second basis, you just can't get all that data and manage all that data at a central location. So this edge computing really is a mechanism to, again, address this data latency and also reduce the volumes of data that actually need to be managed by the headquarters, because you can filter out, the stuff that if it's operating fine, then, I really don't want to hear about it. I know for a fact, Bob, that Duke has said publicly they spend 75% of their time just sifting through the information and 25% interpreting it.
Wow, yeah.
So we could use these edge analytics to sift through, and instead of providing them all the data, only provide them the data that's relevant to a problem. That significantly reduces the amount of analysis they have to do and review of the data they have to do, so that they can focus more on the interpretation side.
Understood.
Right,
yeah.
So again, just kind of to kind of illustrate the same point here. When you look at this cloud, this data center, this central processing, the things that make the most sense to do there are more of the business intelligence, the broader kinds of analytics, and those analytics that don't require the frequency of data. So if you want very low latency or very fast velocity and interpretation, you tend to want to be closer to the edge and focus on the real-time analytics there. So how do these things really get applied in power? Well, certainly with respect to remote monitoring, and this can be applied whether you're an OEM or an owner-operator like Duke Energy. It's with respect to remote monitoring, and as an OEM, you can provide these kinds of services as a service. It could be around monitoring for either performance, reliability, or safety. Those are going to be the three key areas where OEMs and remote monitoring centers can add the most value. When you look at equipment, wind turbines certainly are a logical candidate, but also things like pumps and valves and switchgear and microgrids and transformers. These are things that are well suited for these edge analytics. Right now there's people doing a lot of remote monitoring and analytics on gas turbines and steam turbines, and guys like GE and MHPS are all over that. Where I see an application for these edge analytics is on the smaller components where the cost function needs to be quite different. You can't charge $100,000 a year to monitor a pump. These things have to be embedded into the pumps, and these services need to be provided at a much more cost-effective way, and edge analytics allows you to do that. Finally, I'll give you a brief example. Our company is working with a technology company called Expert Microsystems. They have a product called SureSense. It's a very flexible platform, and their analytics engine, or what they call their analytics kernel, is embedded in their solution. So they have a solution for monitoring. It would be like a remote monitoring. You get the data either through the Pi system or through the cloud or what have you, or it can be done at the plant level. But the data is all collected at some central location and analyzed using these embedded analytics engines or kernels. They have the ability to white label that solution, and in fact, we're helping them talk to different OEMs about the interest in having equipment OEMs, a valve company that knows valves but doesn't know a whole lot about analytics. They can use this solution as a white label, or it can be embedded into a broader solution. So folks that are offering a more broader solution around asset performance management, this can be a way to embed more sophisticated analytics in a broader solution to add advanced pattern recognition or diagnostics or prognostics to that. And you'll notice that there's a common component of all of these solutions, and it's this embedded analytics kernel. And so it's this embedded analytics kernel then that can also be embedded at the gateway, and it can provide these edge analytics. So as we talked about, the analytics that are done within each turbine, or could apply to a valve or a pump right there at the site. This same analytics engine can be used in all these different ways. So it provides a lot of flexibility and interoperability and consistency for a common analytics engine that can be used in a lot of different ways. And I think that's the end of my presentation. I just wanted to at least introduce this edge analytics concept and show how it might apply in the power area. Again, it's a piece of a puzzle that fits very nicely with the concept, the cloud analytics concept that most folks are familiar with.
Scott, before we leave this, can you go back one slide?
Right there?
Yeah. Explain to us, if you're say I'm a valve or a pump supplier, I need the SureSense analytics. What else do I need to offer this package around my valve or pump?
Yeah, for the most part, if you're a valve or a pump supplier, probably the easiest way to get started is with a white label solution that you would use to offer a remote monitoring service. So you would get data through the cloud and analyze that, monitor that, and provide them some. There's a diagnostic capability platform that's built into SureSense that can capture the combinations of different types of faults or different types of failure modes. And as the valve OEM or the pump OEM, they know the common failure modes that to look for, and they know the most likely causes for those. We can actually capture that directly into SureSense, and then use SureSense to continually monitor for all of those symptoms. And when SureSense sees those symptoms occurring in the combinations that are relevant, it'll automatically provide an indication that there's a problem, but also then provide that diagnostic or automatic diagnostic about what the likely cause is. We call it a virtual SME.
Okay.
And so that's kind of the starting point. Ultimately, though, then you can then migrate to this gateway edge solution, where then the next step would be to place this SureSense embedded analytics directly at the gateway or the PLC of that pump or that valve or whatever's operating that pump right now, and then do some of those analytics right there at the edge. You can use SureSense to create these predictive models and then deploy them to the edge, to the gateway or to the server at the device level. So they work and they're totally compatible. But that's really what you need to get started. You really don't need much more other than the issues around getting the data. And that's probably one of the bigger problems. And that's, of course, why some of these edge solutions are becoming so much more attractive. You don't have to get access to the data. A lot of OEMs complain about the remote monitoring services that they could offer, but they're seeing a lot of resistance from the actual plants themselves with respect to sharing that data. And so these edge solutions tend to alleviate the need to take that data through the cloud and provide it to the OEMs.
Yeah, that's good. I'm going to change it and ask you a few questions about something else. But while I'm changing here, let me just have you weigh in on what Howden's doing, for instance, on their fans in mining. So let's see. Okay. Okay. So I'm going to show my screen. But Howden in the mining industry has, as a fan, that mines use to make sure that Russ, you can look and see how back, but make sure I'm back on my screen. But make sure that that the air in a coal mine, for instance, or an iron mine or whatever underground is at the right concentration of oxygen and not a lot of CO and their vapors and so forth there. And so so what they've done instead just furnishing these fans for X is they provide a whole mine ventilation system with the sensors at each one of the places along the mine and each one of the shafts and so forth. It senses CO, it senses explosive levels, and it senses toxic air pollutants. And then they adjust all the fans along the way to make sure that they optimize both the energy consumption and minimize the amount of air that needs to flow through, but at the same time, keep a safe environment. So, I guess from a revenue standpoint, by furnishing a package like that rather than just the fan, they first of all they're able to get a service that's paid for continuous remote monitoring and operation, and secondly, the revenues are probably nearly an order of magnitude larger than just furnishing the fans. So and certainly the data analytics then is part of that package. But let me just go to some of these other things that we had here. We in our most recent newsletter, we're quoting Scott and some other people as well here. But so Emerson, for instance, in their analytics does talk about the deep equipment knowledge and seek the brain input. So I think a lot of the things that you're saying there, Scott, I mean, you do need these subject matter experts. And then so deep knowledge again is what is needed to make maximize the success of all this. And again, Emerson talks about that in this particular article. And then here's another thing, and maybe I'd like to get Scott to comment on this, where this is a very simple system where you've got emission chemicals that are received in 400-gallon totes and used and so forth. But with analytics from Seek, they've actually been able to save quite a bit of money by only injecting the chemicals that they need. And do you have any thoughts on that, Scott, in terms of the relationship of data analytics from someone like Seek here and the whole?
Yeah, I mean, I think there's a great opportunity, and especially in the back end of the power plant. Quite honestly, I think this is an area that's been a little bit ignored. You mentioned the Premex guys; they're focused on trying to do this on scrubbers as well.
Right, right.
Yeah. So there's two aspects of this. One is Seek. I don't know a lot of the specifics about this particular project, but they do a lot of data analytics, unsupervised machine learning to try to create relationships between different variables to try to monitor for performance and such. They might also be, in this particular case, looking at more of an optimization function. So I think the key areas around existing power generation assets is in the data analytics area is monitoring for performance and reliability, and then kind of the third area, which is a little bit different. It's around optimizing. And so there's a lot of work that there's a lot of technologies out there that are now advancing, just as there are in analytics around optimization functions. And so I see a lot of growth in that area, specifically around processes like scrubbers or SCRs. That example at Seek is probably the better example about really trying to optimize around some cost function. The cost function could be, chemical costs versus the emissions levels or what have you. But that's an area in itself, which we also see a lot of opportunity because there's a lot of development going on in that area, and the cost to do those things is getting a lot lower. Bob, you probably remember the folks at NUCO with respect to combustion optimization,
Right,
neural nets,
right.
things like that. You know, it's those same kinds of principles that can be applied to a lot of different processes, and the price to do that is also coming down.
Mm-hmm. I think that this is a real opportunity for these component suppliers, and I think you and I have talked about the fact that you have the availability, and I know a lot of our valve and pump suppliers would probably like to talk to you because they are definitely in thinking how they're going to pursue this whole opportunity. So, do we have any questions from any of our attendees before we wrap it up today? If not, I'd like to thank Scott for his words of wisdom here, and we'll look forward to having you on again with us, Scott, and thank the attendees, and look forward to our next webinar, which will be on gas turbines in about 3 weeks from now. So this is Bob Mcllvaine signing off for today.